We often think about nature responding to things,
Yeah.
wind blows, leaves rustle, an animal runs from danger.
Right. Cause and effect. Reactive.
Exactly. But what if it wasn't always just a reaction? What if, say, plants could somehow sense what's coming?
Yeah.
Almost like predicting the sky.
That sounds a bit out there, I know. But what's really amazing is that a new study is pointing towards something, well, kind of like that.
Okay, intriguing.
Yeah, we're doing a deep dive today into research looking at spruce trees in the Italian Dolomites. And it seems they synchronize their internal electrical signals.
Right.
Not during a solar eclipse, but actually hours before it even started.
Hours before. Wow. Okay, let's unpack this. This sounds incredible.
Yeah.
So our mission today, to get to the heart of this discovery,
Mm-hmm.
we're looking at a study from the Royal Society Open Science. Researchers, Professor Alessandro Chilario and Professor Monica Galliano.
That's right.
And the headline finding, the really stunning part, is this idea that the trees weren't just reacting to the light dimming. They seemed to be, I don't know, getting in sync electrically way ahead of time.
Exactly. That's the core observation. This took place in the Dolomites. Beautiful place. And it showed this forest-wide coordination, bioelectrical signals in the spruce trees there. And like you said, crucially, this wasn't just a response to the dimming light itself.
How did they even measure that?
Well, they used these custom-built sensors, really specialized, ruggedized, low-power ones.
Okay.
Yeah, designed to meticulously track these very subtle signals over time. And that's how they found the synchronization happening significantly before the eclipse peak.
Okay, but here's where, for me, it gets even more fascinating. The study also suggested, didn't it, that there was almost like a leadership role.
Yes, precisely. It seemed the older spruce trees showed a stronger reaction, and they reacted earlier.
Earlier, so like they were the first ones to pick up on it.
It appears that way. Almost as if they sensed the change first, and then perhaps their signals influenced the younger trees around them.
So what does that imply? Like wisdom in the woods?
Kind of. If you think bigger picture, it suggests older trees might hold what Professor Galliano actually calls environmental memory.
Environmental memory.
Think about it, right? These ancient trees, they've lived through countless seasons, storms, maybe even other eclipses.
Right, they have a history.
Exactly. And that history could be, in a way, encoded biologically, allowing them to anticipate, maybe even, prepare the younger trees for these big environmental shifts. Professor Galliano describes them as memory banks of past environmental events. And that makes them really crucial for the forest's resilience, its ability to bounce back.
So this memory could help the whole forest, say, prepare for less light, conserve resources better.
That's the implication, yeah. A collective preparation potentially triggered by the elders.
That is a powerful image. And Professor Galliano, she also mentioned something about the wood wide web, right? Seeing it in action.
She did. And for anyone listening who hasn't heard that term, it usually refers to the underground network of fungi.
Right, connecting tree roots, sharing nutrients, signals.
Exactly, sharing resources, maybe even sending chemical warnings. This study suggests that these bioelectrical signals could be another layer, another vital communication channel in the forest system.
So more than just chemicals moving through fungi.
Well, yeah, and Professor Chilario adds another really interesting layer here. He suggests this synchronization isn't just about physical stuff moving through the fungal network.
Oh.
Their analysis, which got pretty sophisticated, using things like complexity measures and even concepts from quantum field theory.
Oh, okay.
It points towards something maybe deeper, a previously unrecognized dynamic synchronization, as he puts it.
So not just passing molecules back and forth.
Seems not entirely. While the wood wide web is definitely important, there appears to be this other electrical level communication happening. He used this great analogy.
Yeah.
Picturing the forest less like separate trees and more like an orchestra of phase-correlated plants.
An orchestra. I like that.
Yeah, where the electrical activity across the whole forest sort of rises and falls together in time, like instruments playing in sync.
That suggests a much more integrated system than we usually imagine.
Absolutely. Way more integrated, more responsive.
So what does all this mean then for how we should understand forests? It really feels like it shifts things, doesn't it? Beyond just seeing trees competing for sunlight and water.
It really does raise fundamental questions. This research adds, significant weight to the idea that plants exhibit complex, coordinated behaviors.
Almost like animal groups?
Well, people are increasingly making those comparisons, yes. Professor Galliano said this reveals a new layer of complexity in plant behavior, and that phrase, I think, really captures this shift in perspective.
A new layer of complexity.
Yeah. It suggests forests are much more interconnected, much more aware, maybe, than we've typically given them credit for.
And thinking practically, this isn't just some, abstract scientific curiosity, is it? It must have real implications for conservation.
Oh, absolutely. Very clear implications. The finding that the older trees seem to lead this anticipatory response, well, it really underscores why we need to protect them.
Because they hold that memory.
Exactly. As Professor Galliano puts it, protecting these older forests is vital because they're preserving and transmitting invaluable ecological knowledge.
Right.
If we lose those ancient trees, we might be losing a critical part of the forest's ability to adapt, to respond to future changes, climate change, other stresses.
Their memory, that accumulated experience, could be essential for the whole ecosystem's health long term.
Precisely. It's like losing the wisdom keepers, the elders of the ecosystem.
Wow. Now, I heard this research is also going to be featured somewhere more publicly accessible.
Yes, which is great. It's going to be part of a documentary. It's called Il Codice del Bosco. That's the Forest Code.
Oh, okay.
It's scheduled for release in Italy in May 2025. It'll be really interesting to see how they visualize this, how it connects with a broader audience.
That's fantastic. It's so important for this kind of work to get out there. And of course, research like this doesn't happen without support.
No, definitely not. We should acknowledge the funders. There were several involved.
Yeah.
Zenit Arti Audiovisive, Open Azienda SRL, Primo Principio Societa Cooperativa, IGA Technology Services.
A real group effort.
And also the Templeton World Charity Foundation and the H2020 European Research Council.
That's quite a list. And if you listening want to read the actual paper.
Right. If you want to dive really deep, the study is in Royal Society Open Science. The title is Bioelectrical Synchronization of Piscia Ibis During a Solar Eclipse. Chiolario, Gagliano, and their colleagues are the authors.
Great, thank you. So let's try and bring this deep dive together then. The key takeaway seems to be this compelling evidence that spruce trees, well, they don't just react.
No, they seem to anticipate specifically this solar eclipse.
With the older trees potentially playing this coordinating role, leading a synchronized bioelectrical response hours before the event.
Yeah, suggesting a really sophisticated highlighting the vital, maybe underappreciated role of these older trees as, well, keepers of ecological wisdom.
It certainly makes you think differently.
It really does. And maybe that leads us to a final thought for you, the listener, to ponder.
Okay.
Given this interconnectedness, this apparent anticipation we're seeing in trees, what other kinds of subtle communication, maybe even forms of intelligence, might be out there in nature, things we're only just starting to perceive?
And what does discovering that mean for us, for how we see ecosystems, how we interact with them?
Exactly. What are the really big implications for how we view, and maybe more importantly, how we treat the incredibly complex and delicate natural world around us? Something to think about.